Lesson 7.2, Division Property of Exponents. So what we're going to talk about right now is what happens when you divide exponents, because there's some properties that you have to apply. But first, do you remember when you would have to reduce a fraction? And we still have to reduce fractions. But let's just look at 12 sixtieths, or 12 divided by 60. So if we use the prime factors, 12 would be 2 times 2 times 3, correct? Yeah, which is 4 times 3. 60 would be 2 times 2 times 3, then times 5. So if you expand this out, you say, okay, well, what is going to cross cancel? And you could basically just cross off when you have the same number at the top as the bottom, because when you divide, it becomes 1. So if you crossed off this 2 divided by 2 is 1, 2 divided by 2 is 1, 3 divided by 3 is also 1, and what are you left with? You are left with 5 in the denominator, and really, there is an invisible 1 up here, and that's why it reduces to 1/5, okay? So this is still true when you're working with exponents. If you expand this says w to the 5th power times z to the 4th power divided by w cubed. Okay, I just expanded this out. You've got 5 w's multiplied together, 4 z's, and at the bottom you have 3 w's. What do you think is going to happen to the w's? Okay, they're going to cancel out, or because, you have W on top and W on the bottom, that just becomes 1. So how many W's can you get rid of? 3, okay? And you're left with 2 W's and 4 Z's, okay? Which leaves you with W squared times Z to the 4th, okay? Really, as a shortcut, the property is when you divide exponents, you just subtract, okay? And you would have seen that. Look, 5 minus 3 is 2. All right, and that ends up in the numerator, of course. Okay, let's talk about another 2 properties. Anything to the 0 power is 1. So if I say, for example, x to the 0 power, it is not 0. It is not 0. It is actually 1, okay? And then if you have a negative exponent, it is going to flip. So if it was in the denominator, it's going to come up to the numerator. And if it is in the numerator, it will come down to the denominator. So let's take a look at this. You have 3 divided by x to the power of negative 2 times z. So you take the monomial that has the negative exponent, and it goes up. When it goes up, it becomes positive, right? So it becomes 3x squared. So that negative became positive, and that z is still in the numerator, okay? Denominator. Okay, let's take a look at this one. 5x to the power of negative 4 divided by x squared times z cubed. What do you think you need to do with the negative term, or the negative exponent, sorry. What do you think you need to do with the negative exponent? Okay. It needs to come down to the denominator. And since your x's are like terms, when you bring it down, it's really the opposite of subtraction, okay? Because, let me just show you this really quick. Here's what's happening. When you bring it down and it becomes positive, then you have x squared, you bring it down, x to the power of 4, and then multiply it by z cubed. So 2 plus 4 is 6, okay, times z cubed.
All right, well, we're going to go ahead and pick up. Here's a few more things that you need to know in order to do your work correctly. We'll start by filling out this chart. I find that this is one of the most helpful things that students ever really go through. So this is a whole bunch of exponents in a row on the same base, right? 2, and I went from the 5th power all the way down to the negative 4th power. Let's start with one we know. What is 2 squared? 2 squared is 4. And let's go ahead and count up from there. 2 squared is 4. I'll slide this over so I can. 2 squared is 4. 2 cubed is 8. 2 to the 4th, that's 8 times. All we're doing is multiplying by 2. Each time we go up, we're multiplying by 2. So what's 16 times 2? That's going to be 2 to the 5th. That's going to be 16 times 2 is 32. That was in a previous part of this video. 2 to the 1st then. 2 just one time is 2. And again, the idea is however many it says it's 2 times 2 times 2. Well, if you keep on doing this, in order to go this way, we have to multiply by 2. So what do you have to do in order to go this way? You divide by 2. That's one way of saying it. That's usually what students tell me, and that's fine. I want you to understand that when you're going that way, you're really multiplying by 1/2. This has to do with your understanding that division is really multiplication by a fraction, but this is probably something we have to explain more in class. Anyways, 2 to the 0, 2 to the 0, anything to the 0 power is 1, and that fits, because 2 divided by 2, or multiplied by 1/2, is 1. What's 1 multiplied by 1/2? It's 1/2. What's 1/2 multiplied by 1/2? 1/4. What's 1/4 multiplied by 1/2? 1/8. And what's 1/8 multiplied by 1/2? 1/16. Now here's the thing. You just start to notice very quickly that there's some sort of relationship between 2 to the 4th and 2 to the negative 4th. And what is it? It's that they're the same number, except what? Except that if it's positive, then you have a normal like 16. But if I have a negative exponent, I get what's the reciprocal of that? 1/16. We usually just talk about this as if it flips, the top and the bottom, they just kind of flip positions. So yes, that is what's happening, and anything works that way. I like to say something like this. 7 to the 3rd, anyone know what that is? It's 343. What do you think 7 to the negative 3rd is? And if you can answer that, then you understand the concept that I'm trying to address right now. 1 over 343. That's the whole point of this concept right now. That a negative would reciprocate what the positive is. Okay? So keep that in mind. We're going to run through one more set of examples. What is 10 to the 1st? It's 10. What's 10 squared? 100. For those who don't know, the rule on tens, and this is for scientific notation, you should know this, and your science teachers wish that we would teach you this, so please pay attention because you're being taught. 10 cubed then is a 1 followed by 3 zeros. Now 10 to the 7th would be a 1 followed by 7 zeros. 10 to the 0 is a 1 followed by 0 zeros. 10 to the negative 1 is a 1 followed by negative 1 zeros. 10 to the negative 2 is a 1 followed by negative 2 zeros. 10 to the negative 3 is a 1 followed by negative 3 zeros. That's not really how it works. What's really happening here is this is 1/10. This is how we write 1/10 as a decimal. What's really happening here is this is 1/100. This is how we write 1/100 as a decimal. It just happens to be really convenient that, again, if you're wondering, if you can remember just to flip that decimal spot, these are going to be related all the time. 1/1000th. That's how you write it as a decimal. Okay? Alright, classic class, we're going to give you a few examples before we send you on the road to do your job. So here we go. Negative 4n squared q5 r squared over 9n cubed q squared r. Oh man, there's so much going on this. And what is the answer? 1. Why? 0 power. Game over. Anything to the 0 power equals 1. Doesn't matter what that stuff is inside. Number 2, x5 y0 over x cubed z. Let's start with what's very obvious that we can simplify. Y to the 0 is 1. Y to the 0 is 1. So that's going to give you x5 over x cubed z. Start with x5 over x cubed. x5 over x cubed. You could take this up if you wanted to, and that would turn into x5. Bring this up. X minus 3 over z. 5 minus 3. That's going to be x squared over z. As you can see, the z stayed the whole time. We never really did anything. This turned into 1. So the x5 and x cubed, the only thing we really had to balance out. We got 5 on top, 3 on bottom. They cross off, you're left with 2 on top. Let's slide over. 3, 4, 5. And this is on page 402, 403. Number 3. N to the negative 5, p to the 4th over r to the negative 2. Really simply, make everybody positive. Okay, p to the 4, stays. N to the negative 5 goes to the bottom. R squared becomes positive in the top. Even though that's awkwardly balanced on the line, that's good. That's exactly what I want. Everybody's a positive exponent. We're going for that for right now. Number 4. Again, make everybody a positive is probably the easiest thing. Okay, well, if that's the case, then I leave the 5 at top, and I leave the t to the 4th at top, and I bring up the w to the 5th at top. This r to, so this went up. This is going down. Negative 20 stays, r squared stays, r cubed now, and t to the 7th. So what do you get? I get 5. Uh, well, let's go ahead and do this. T4, T7, what does that turn into? Bam, cross that off. Minus 4 from here. That's going to, 7 minus 4, it's going to be 3. So 3. W is going to stay. Negative 20 is still here. R squared and r to the 3rd is r to the 5th. 5 and negative 20 is going to simplify to make it w to the 5th over negative 4r5 t cubed. Okay? So that's kind of what we're going for on that one. Sorry to be quick. You can review the steps if you need to. Last one here, 2 and 10. Bam, 1, 5 right off the bat. Move this one up. That's going to become A5. Move this one up. That's going to become B4. Remember to swap places with these or something like that. Maybe you choose to add 4, add 4. So bam, the c is gone. That's going to be c to the negative 1. I don't want c to the negative 1, so I'm going to make it a to the 5th, b to the 4th over c. And that's my final answer. Thanks for listening.